I'm Anil Kumar, and in this video, we'll discuss few concepts about extreme values in closed interval. So let's begin with this statement which says a continuous function in closed interval will always have absolute maximum and absolute minimum. So let's try to understand this statement. What does it really mean? Okay, let's have a function here. So I'm just sketching a function kind of like this. Okay, we make let's say closed interval. So let's say this function begins from some value, ends, and let's say this point is A. These are the turning points. Let me name them as A, B, C, D, and E. So what we observe here is that we have a function which is continuous in a closed interval. So we'll say f of x is a function and the closed interval is from A to E. So this is a function in the closed interval A to B. The statement is a continuous function in closed interval will always have absolute maximum and absolute minimum. So as you can see here, we do have a value which is absolute minimum. There's nothing lower than this value, is it okay? And there's nothing higher than that. So these values are called absolute this is maximum, and this is called absolute minimum. So these are our extreme values, correct? We do have few local maximum minimums here, one of each kind. This is a maximum in small vicinity. We call this as local maximum. Let me write it in short, and this one is local minimum, right? So these are different terms which you are going to come across while understanding questions on extreme values in closed interval. What you also see is that this is also a local maximum, but a local maximum could be an absolute maximum also, right? Another thing which we observe here is that all the points which are related with absolute maximum, minimum, or local maximum, minimum have something very important to share. That is, we find that extreme values can be at turning points, they could be at ends. So if we are working on a closed interval as we have here between A to E, value of the function at A, value of the function at E, that is from the closed interval, could result into absolute maximum or minimum, could, right? In this case we see that f of A is absolute minimum. And we also see that if the derivative of the function is 0, the turning point, or if the derivative of the function does not exist, I should say, not defined, then also we can have absolute maximum or minimum, correct? So these are few observations which are very important to make, and these observations will help us to solve most of the questions in the unit on extreme values in closed interval. So let me summarize here what we are trying to say, and let me also give you a few terms, we have Fermat's theorem, which says that the local maximum is either, so this portion is called Fermat's theorem, which says that the, let me change the ink, local maximum or minimum occurs at f dash x equals to 0 or f dash x not defined. That is one part. So, or you say does not exist. Better thing is use does not exist. So in a sharp corner it does not exist, correct? So that's the Fermat's theorem. So local maximum minimum can occur only, I should say only, at a point where f dash x equals to 0 or f dash x does not exist. And we call these points as critical numbers, right? So we'll call these points as critical numbers. Okay. Secondly, if we have a closed interval, then we definitely have absolute minimum or maximum. Local minimum maximum can become absolute minimum maximum also, as you can see here, correct? So these are two things which we have learned, and now let's move on and answer a few questions, correct? Okay, so here's the first one from our learnings. We again have the knowledge of previous section. A continuous function in closed interval will always have absolute maximum and absolute minimum. And here's a question for you. I need to sketch something. Explain why the following functions do not have both absolute maximum and absolute minimum. So I want to give you a few examples and you need to figure it out why they don't have both absolute maximum and minimum. Okay, so let's begin with a very simple example. Let's say we have a parabola kind of like this. As you can see, we do have absolute maximum in this case. However, we do not have absolute minimum. You need to figure out why is it so. Why do we have only absolute maximum but not absolute minimum? Now let's take another example here, and let's take this function which is kind of like this, and this time I'll make a hole here, right? And this is a fixed point. Now in this function, what do we have? Do we have both absolute maximum and minimum? You need to answer this question. And then the last option here for us is, let's say we have a line which is going in this direction, and we consider the line only from point A onwards. So we are considering in this particular case x belongs to from 0 to infinity, correct? So in these three cases, explain why we do not have both absolute maximum and minimum. The reason is very clear. In the first case, the function is continuous, but the interval is not closed. See, the interval here is from minus infinity to plus infinity. Do you see that? Since we do not have a closed interval, we may or may not have absolute maximum minimum, and that's the reason why we don't have both. Here, what is the interval? The interval is from, let's say, a to, let's call this 0. So the interval is closed at one end, but not at the other. So the maximum value is actually approaching a value. However, it is not quite there. And therefore, in this particular case, we have absolute minimum and not absolute maximum. In the last case, absolute maximum is not defined, it's approaching to infinity, but we have absolute minimum, right? So it's kind of important to understand that a function will have absolute maximum and absolute minimum only in closed interval when the function is continuous. Do you see that point, right? Let's see another example, and this one is a very interesting question for you. It says, sketch a function in the closed interval -2 to 2 which has only absolute minimum but not absolute maximum. Well, that's very difficult, since we know that in a closed interval we should have both. But the question is, read it again. Sketch a function in the closed interval of -2 plus 2 which has only absolute minimum but not absolute maximum. So let's say this is the coordinate plane. We are talking about an interval from, let's say, -2 to 2. Sketch a function with absolute minimum but not absolute maximum, and it has to be in the domain -2 to 2 closed interval. Well, here is the solution. What you could do is you could sketch something like this. We can have absolute minimum kind of like this, and let's say the function is kind of like this. So it's like asymptotic here. So the absolute maximum is not there since it is asymptotic, right? And we can say this kind of like stops here. Since we are looking into a function which is defined in this closed interval, we can give a value. Let's say 0 at 0. Now, the interval we have considered is closed. And in this case, what you observe here is that we have only absolute minimum, but we do not have absolute maximum. Can you tell me why? Well, the reason is clear. The reason is that the function is not continuous. Do you see that? So it is very important to understand that when we are talking about extreme values, we have to keep in mind two things. First, continuous, and second, closed interval. Then only you'll have both absolute maximum and minimum. I hope that helps you to understand the concept. Feel free to make suggestions. Subscribe to my videos, and if you like, that'll be great. Thank you and all the best.